Let's start with convolution, which is really the core of these networks. I will try to explain it with an example. So we are seeing two images here, and I would like to know if they are the same. And most of us would say, well, yes, they are two axes. They are both images of axes. They belong to the same category. They are both axes. Would this be the same answer for a computer? Depends what model you're using. If you weren't using a convolutional neural network, and any of the other models would just superimpose the two images, and by superimposing, the computer would say, no, these are not two axes, because actually most of the points don't overlap. So in order to make a machine and an algorithm understand whether two images belong to the same class or not, you cannot just superimpose two images point by point. You need to use a different strategy. And the strategy that we use is called convolution. What convolution means is basically, instead of just superimposing two images, the whole perimeter of the images, you use some filters that are smaller. And each of the filters is testing a specific characteristic. So for example, this filter is an oblique line, right? So you superimpose the smaller filter on the image in order to test on smaller portions of the image if that characteristic exists or not. So if you were to do that, then you would see that both of the images actually have the same characteristics. They're just positioned in different places. Mathematically, what you do is just the dot product between the filter, which is the smaller matrix, and the image, which is the bigger one. The result of it, so the dot product between the smaller matrix and the bigger one, which is the image, is called a feature map. It's just a matrix that represents whether that feature was present in the image or not. And for each of the convolutional layers that we have in the network, we actually have a lot of filters.